We are live. Hi everyone, welcome back to Code Era. Today is the session number 7 for the series that is Mastering Code Forces Sorting Problems, live problem solving. And this is the 7th lecture. So just quickly give me a +1 in the chat and like the video as well if my voice is audible to everyone and my screen is also clearly visible. And then I'll be waiting for some time for everyone else to join in and then we'll start with the session, right? So up till now we have discussed a lot of problems that were rated between the range 800 to 1300 or 1400, right? Now in this video we'll be discussing two more problems, and you can see this problem that is named as Mere array. It's rated something as 1300 on CodeForces, and we also have a problem that is rated as 1400 on CodeForces, right? So these are the two problems that we'll be discussing today. The first problem name is Mere array and the second problem name is RationalLee. Hi Vanshika Kapoor. Okay, so in these two problems we'll be using sorting. We'll be watching like how we actually need to use sorting in such a way that we are able to come up to the final output that has been asked from us, right? And the template is also ready. I'm just waiting for I'll just wait for 1 or 2 minutes more for everyone else to join in, and then I'll start. Okay, hi Chirag. Right, so these are the two problems that we'll be discussing. One is rated as 1300, another is rated as 1400. Apart from this, one more thing that I wanted to tell you, that if you feel that we can take some problems, like if you want to suggest some problems, so you can also suggest some problems in the chat. Like after the session is over, you can suggest some problems in the comments, and I am open to taking those problems as well, because we are trying to solve your doubts as well as we are trying to level up, right? So I guess 6 people have joined, so please quickly consider giving a +1 in the chat and like the video if you haven't done that, because I want to begin as early as possible, right? So all those who have joined, can you please quickly give me a +1 in the chat and like the video as well, and after that I'll be beginning with today's problems. And up till now, like, do you think that we should have more lectures on sorting, or we should start with some new topic? Because this is the 7th session, so you can also let me know that in the comments. Right, now moving on, let's start with this question. Shall I start? If everyone agrees that we should start, so please consider giving a +1 in the chat so that I can start with this question. Shall I start with this question? What do you say? Shall I start with this question? So the first problem that we are going to discuss today is named as Mere array. It was asked in CodeForces round 665, which was rated for division 2, and it is a problem C, right? It's a problem C, means that it is something that people will try to solve, right? So it says that you have been given an array. Hi Ria. You have been given an array where all AI are integers greater than 0, right? So you have been given an array where the all the integers are there, that is all the natural numbers are there, integers greater than 0, right? And in one operation you can choose two different indexes I and j, such that it says that you have been given an array and all the elements of the array AI are greater than 0, right? You have been given this array and it will be having n elements, right? Now it further says that you need to choose two indexes I and j, such that if my GCD of a of I and a of j, if the GCD of both these elements, if the GCD is equal to the minimum element of the whole array, then you can swap AI and AJ, right? So if the GCD of AI and AJ is equal to the minimum element of array, then you can swap AI and AJ, right? It is possible to swap AI and AJ. So you have to choose two indexes I and j, such that if the GCD of AI and AJ, that is GCD of AI comma AJ, if it is equal to the minimum element of the whole array, then in that case you can swap AI and AJ, right? This is what you can do. And what you have to do in this problem is, now you want to make an array that is non-decreasing using these operations. So you have to determine whether it is possible to make a non-decreasing array or not. So you have to make an array in ascending order, or you can say non-increasing order. That is, A1 should be less equal to A2, should be less equal to A3, should be less equal to A4 up till less equal to an, right? So this should be the array after that, right? So it says that you have to choose two indexes I and j such that between two elements GCD of ai and aj is equal to the minimum. If it is equal to the minimum element of the array, then in that case you will swap ai and aj, and by doing several operations like this you have to tell that whether it is possible to make the array sorted or not in ascending order, right? Is this much part clear to everyone? Please quickly let me know in the chat. Is this much part clear to everyone? is is this much part clear to everyone? Please quickly let me know in the chat. Is the problem statement clear? If the problem statement is clear, please quickly give me a +1 in the chat. Is the problem statement clear to everyone? Is it? You can just consider giving a +1 in the chat if the problem statement is clear. You take two indexes I and j such that if GCD of AI and AJ are same, if the GCD of AI and AJ is equal to the minimum element of the array, then in that case what you will do is you will simply swap AI and AJ, and by doing several operations like this, by choosing several I's and J's, you have to tell that whether it is possible to make the array in ascending order or not. Okay, right? It is clear to some people, right? All others can also mention that, right? So in this problem, let's say that we have been given some test cases as well, right? So let me take some test cases in this problem, then we can understand the problem a little bit better. So let's say if you have been given n is equal to 1, right? If n is equal to 1 and the element is 8, right? So in that case you will always return a yes, because this is always sorted, right? One element is always sorted. Let me copy the answers as well. Okay, we don't need to do that, maybe. Yeah, right. So since there is only one element, so in that case you don't need to worry about it, right? Let's say if my n was 6, if the number of elements was 6 and these elements were nothing but 4, 3, 6, 6, 2 and 9, right? If these were the elements, right? If these were the elements, then what will happen? If these were the elements, then what will happen? What is the minimum element in this case? Can I say that the minimum element in this case is nothing but 2, right? I can say that the minimum element is nothing but 2. Now how will the actual sorted order look like? Can I say that the sorted order should look like this? Let me write it using a different color. Let me write it using a yellow color. Can I say that in the sorted manner it should look like 2, 3, then 4, then 6 and 6 and 9, right? This is how it should look like, but actually here it is not looking like that. But what is the minimum element? Can I say that the minimum element is nothing but 2? Yes, the minimum element is 2. So what I can do, can I say that I can swap these elements, right? How can I say that I can swap this and this? Can I say that I can bring 2 here and 6 here, right? Now can I say that I can swap this 2 with this 6, right? If I swap them, then what will happen? Can I say that this will become something like the GCD will also be coming 6, right? Because GCD of 2 and 6 is what? 2, right? That is equal to the minimum element of the array, right? So now I can say that I can bring this 6 here, I can bring this 6 here, and now my 2 is here. Can I say that? Yes, I can say that. Now my 2 is here. Now notice one thing, that now I don't need to swap this position, I need to swap this position. So can I say that my GCD of 4 and 2 is nothing but 2, which is my minimum element? So can I say that I can swap this 4 and this 2? Yes, I can swap. So what will I do? I'll bring 2 at the first position and 3 is here same, and I'll bring 2 at this position and 4 at this position, right? So in this way I can see that now it is sorted, and it is sorted in non-decreasing order or ascending order, right? So for this case I will print a yes, because I can do that, right? Is this much part, is this test case clear to everyone? Please quickly let me know in the chat. If the test case is clear, please write clear in the chat. If this particular test case is clear to everyone, you can just consider giving a clear in the chat. Write a clear in the chat, so that I know that it is clear to everyone, right? And also if you haven't liked the video, consider liking the video as well, right? So is this part clear to everyone, that for this case I can do this, right? I can write a yes for this case. I have also explained how. Okay, what about others? I also want others to just quickly let me know. If it's not clear, we can discuss it again. There's no issue with that as well. Clear. Okay, what about others? Just quickly let me know. Quickly, you can just let me know. Is it clear to others as well? Okay, let me explain this again, right? Maybe some people might not be clear with this. So let's say if this was 3, 4, 3, 6, 6, 2 and 9, right? So the actual sorted order, in the actual sorted order, what it should look like? It should look like 2, 3, then 4, then 6, and 6 and 9. Now it says that you can change two elements, that is AI and AJ. You can, if the GCD of AI and AJ is equal to the minimum element, then in that case you can do what? You can swap AI and AJ, right? You can swap these two elements, right? This is what the question says. Now in this, what happens is let's that the minimum element is what? The minimum element is this 2, and the element this 6. I need to bring this 6 in this place, right? So what I can do is I pick these two. What is the GCD? What is the GCD of 2 and 6? Can I say that the GCD is nothing but 2? Yes, the GCD is 2, so that means I can swap 6 and 2. So I've swapped 6 and 2. What does this become? So this becomes nothing but 2 comma 6, and this becomes 9. This is 6, this is 3, this is 4, right? Now after that, what happens is I pick this element and I pick this element. I know that this 6 should come in this place, right? I know that this 6 should come in this place. So I see what is the GCD of 2 and 6. It is 6, it is 2, right? So that is, it is equal to the minimum element. That is, minimum element is also 2, right? So that is why I can swap this 2 and this 6. So this becomes 2, 6. The others element remain the same, right? After that what happens is, now notice one thing, that 3, should I change 3 and 2? No, I shouldn't be changing them. The reason for that is because I think that 3 is at its correct position, right? Now what I can do is I can pick this 2, and I can pick this 4. And what is the GCD of 4 and 2? The GCD of 4 and 2 is nothing but 2. So for this case, what will happen for this case is that 2, 3, 4, then 6, 6 and 9, because I could swap them, right? And can I say that this is nothing but a sorted order, or I can say in a non-decreasing order or ascending order, right? Non-decreasing order, right? If this much part is clear, please quickly give me a +1 in the chat. If this much part is clear, please you can consider giving a quick +1 in the chat, so that I know that this particular test case now should be clear to all of you, right? If it's clear, you can just quickly give me a +1 in the chat. Only then I'll be able to proceed further, right? Is it clear? Is it clear to everyone? Is this much part clear to everyone? Please let me know quickly. I hope that it is clear to everyone. Right, this is how I'm picking the elements. I'm just explaining you this particular test case, right? Now let me try and explain you other test cases as well. Maybe we can find some pattern or things like that in them, right? So now let's do this again. Yeah, right, Ria is giving a +1, correct. Okay, perfect. Right, so let's say now the number of elements that I am having is 4, right? Number of elements I have is 4, and I have this array 4, 5, 6 and 7. So can you see that it is already sorted, right? If it is already sorted, then I'll print a yes for this case, right? Now let's take the other example. That is 7, 5, 2, 2 and 4, right? So let's try and take this another example and see what we can do with this one, right? Let's say if my n is equal to 5 and the elements I am having are 7, 5, 2, 2 and 4, right? These are the elements that I am having. Now in this case, what I can do, just quickly let me know. Can I, if I can I rearrange it in such a way that I can make it sorted? Can I do this? Anyone can let me know. Just let me know a little quick. What can I do in this case? What can I do in this case? Is it clear? Right, what I can do for this case, is I can say that this is not sorted, right? So what I'll try to do, I want the GCD. I know that if the GCD of two elements, if the GCD of AI and AJ, I choose two elements, AI and AJ, and if the GCD of AI and AJ is equal to the minimum element, then in that case I can swap them, right? So I need to bring this 7 here. I need to bring this 7 in this place, right? I need to bring this 7 in this place. Can I do that? Can I do that? Can I do that? I need to bring 7 in this case, this place. Can I do that? Can I do that? No, I cannot, right? Why? Because if you take this 7, so the GCD of 2 and 7 is nothing but 1. Also the right, also the GCD of let's say 7 and 4, it is also 1, right? So it is not equal to the minimum element, so that is why no swap is possible, right? No swaps are possible. Like the GCD, since 7 is a prime number, so the GCD of 7 and all the other numbers are not its factors, so the GCD of 7 5, or you can say 7 2 and 7 4, all these will come out to be 1. All these come out to be 1, right? So for this case, I cannot swap this 7 such that I bring it to this position, since 7 is the largest element, so I wanted it to be at the last position in this array, right? But I cannot do that. I hope that this is very much clear to everyone, right? Right, so that is why what will I do? What will I do in this case? What will I do in this case? That is why what will I do in this case? I will write a no for this, right? Everyone agrees to this? Is this test case clear to everyone? Please quickly let me know. Please quickly let me know, is this test case clear to everyone? Is this particular test case clear to everyone? If it is clear, then please quickly give me a +1 in the chat. Okay, it's clear. Okay, to Ria it's clear, right? Okay, perfect. Right, these are the test cases that we need to just think a little bit on. What's not clear, man? Chirag, what do you think is not clear? Right, if I am having this array, uh, let me just increase the font size. Answer will be no for this case. I am saying that the answer will be no for this test case, right? Answer will be no. Why the answer is no? The answer will be no in this case, uh, because for this case I cannot make it as sorted, right? And I cannot make it as non-decreasing, because I can never bring this 7 to this place, right? Because the GCD of 7 with any other element will any other element present in the array will never give me a GCD or equal to 2. That is the minimum element, right? So that is why I can never make it. Right, this is, if I hope that this much part is clear to you. Right, now moving on, how do we observe a pattern? Is there any pattern? Is there any pattern in this question? Just let me know. Is there any way to do this question? Now how do you determine how do you determine yes or no? How do you determine yes or no? How do you determine yes or no in order of n time? Right, in order of n time, how do you determine that? Can someone let me know? Can someone in the chat let me know? Like in order of n, or it's, let's say, in use, even if you use something like sorting. So let's say, how will you do this without using a brute force, without getting a time limit exceeded? How will you determine that whether you can do this or not, whether you can make it sorted or not? How will you do this? How will you do this? Just quickly let me know, otherwise I'll be always telling the answer, but if you want, you can answer that as well, right? How can we do this? Any answer would help from your side. Any particular observation that you guys can make, or anything like that? If you can, if you have any other any approach, you can just let me know. You can just let me know. First of all, can I say that once I'll be getting, I can say that I'll be getting the array, I'll be marking my flag as 0, and I'll start I from 0. I is lesser than n minus 1, right? And I plus plus, because I'll be checking for all the pairs, right? If my a of I is lesser than a of I plus 1, if the left element is lesser than the right element for every pair, then in that case it will be always be fine. Okay, in that case I'll say I'll continue, right? Else can I say that make another sorted array and compare? Yeah, that is possible, but how you would do it? Like, how would you use GCD in that? That is the main concept behind it, right? In the else part, what I'll do, I'll mark my flag as 1, indicating the array is not sorted, and I'll break. And if my flag is 0, so that means that if currently my flag is 0, so that means that the given array is sorted, so I'll print a yes for this case, right? Otherwise I'll do the computation part. And what will I do? What will I do here? Right, what will I do is the task that lies ahead of me, right? After that, what will I do? Can someone let me know in the chat? Ria or other people, can you let me know what will I do? What will I do? What will I do now? What should I be doing now, right? So what I can do is I can have an array b, which will be having the elements of the array a, right? And what I'll do is I need to have another array that is replica of array a, and it needed to be sorted, right? It should have been sorted, so I'll sort b. I sort b in ascending order, right? In non-decreasing order, I sort it, right? After that, what will I do? Once I'm done with this much part, so what will I do next? Now I can say that I can swap two elements. Let me take the sample test case in this 4 3 6 6 2 9. Okay. So if this is 4, this is 3, this is 2, this is 6 6 2 9, right? Just give me a minute, right? 6 6 2 9. Can I say that I can swap a particular element? I can swap a particular element if the GCD, if it's GCD, if the GCD of a, if the GCD of the minimum element, let's say the GCD of the minimum element with any other element, that is ai, is equal to mi, right? If the GCD of the minimum element with any other element is equal to the minimum element, can I say that I can always swap? Can I say this? Like I had to swap this 6, I had to swap this 6, I had to swap these 4. Can I say that 4, 6 and 6 are all divisible by 2, that is the minimum element? All are divisible by 2, right? All are divisible by 2, that is the minimum element, right? Can I say this? Just quickly let me know in the chat. If the element is divisible by the minimum element, then in that case I can swap it, because if the element is divisible, then in that case the GCD of mi comma the ith element that I am taking will be what? It will be mi, and it will always follow the condition. So I can use my minimum element as a floater element to swap in whatever situations I want, right? Is this much part clear to everyone? Please quickly give me a +1 in the chat if this part is clear to everyone, right? Yeah, it's clear to Ria. What about others? You can also let me know. I'm saying that let's see in this test case what was happening. In this test case, I had to get the GCD 2, right? I had to get the GCD 2. So can I say that if my GCD of the minimum element, that is 2, with any other element is equal to 2, so in that case I'll always be able to swap all those elements, right? So I can swap this 4, I can swap this 6, I can swap this 6. Why I can swap all these elements? Because they are divisible by 2, that is the minimum element. And if they are divisible by the minimum element, then so in that case the GCD of the minimum comma a of I, the ith element, will be equal to nothing but mi, right? So if the elements are divisible by 2, then that means the GCD of 2 and 6 will be 2, the GCD of 4 and 2 will be also be 2, and the GCD of 2 and 2 will also be 2, right? Is this much part clear to everyone? Just quickly let me know. Yes, I hope that this much part is clear, right? Okay, perfect. Now this is what you need to do in this question only, right? This is what you need to implement in this question, right? What you will do is in the else part, what you will do is you will simply first of all find the minimum element, right? You have to find the minimum element, right? Once you have the minimum element, so what you do is you start I from 0, and I is lesser than n, right? And you do an I plus plus, right? You iterate for all the indexes. If my a of I is not equal to the b of I, right? So if the ith element is not at its position, notice that this is the sorted array, right? This is the sorted array, and this is the not sorted array. So if it is not at its position, so in that case you can use the minimum element as a floater element, right? You can use the minimum element as a floater element, right? So in this case what you can do is, if I'll say that if my current ai mod 2, if not 2, mod minimum, if it is divisible by minimum element, then I'll say okay, I can continue, right? I can continue. Else I'll break from the loop, and I'll mark my flag as 1, indicating that I can never make it sorted, right? Is this much part clear to everyone? If I wanted, let's say if I wanted 7 to be at the last position and the minimum element is 2, then I'll never be able to make. What if 3 and 9 are other element not in place? So in that case I'll print a no. In that case, if 3 and 9 are not at their position, then the minimum element can never be a floater for those elements, because the GCD will come out to be 1, and in that case you will never be able to sort them, right? Is this much part clear to everyone? I hope that this much part is clear to everyone, right? So let's quickly write down the code for this particular problem. Let me have a look. Okay, right. So shall we write the code for this problem? I think that we should. Okay, just increasing the font a little bit. Right, so in this problem I'll be given long n and I. After that, what will I be given? I'll also be taking let's say c in n, that is the size of the array. Then I'll be having long array of n and b of n, that is the two arrays. After that, what I'll do is I'll first of all take the array as an input. So what I'll be doing is I'll be taking so, and I is lesser than n minus 1, so I'm checking for all the n minus 1 pairs. Right, what I'm checking is if my a of I is lesser than a of right, if my a of I is lesser than a of I plus 1, right, so in that case what will I do? I'll mark my flag as 1. I'll mark my flag as 1 and I'll break from here. Right, is this much clear to everyone? You can just let me know. I'm just looking at right, is this much part clear to everyone? Is it clear? You can just let me know. Is this much code clear to everyone? Right, so I'll simply break, and what I'll do is I'll check after this loop is over that if my flag was still 0. So in that case what will I do? In that case what will I do? In that case I'll simply say that I'll say see out yes. Let's see out a yes, because it is sorted. Right, it is already sorted, so we do not need to check. Otherwise, in the else part, what I'll do is I'll mark my flag again as 0. So I'll assume that okay, I can make it as sorted. Right, after this what I'll do is, let's say I also have a vector. That will be storing all the elements which are not divisible by the minimum element. Right, I'll be having the long minimum is equal to what? Let's say minimum is equal to what? Star min underscore element and a comma a plus n. Right, this is how you can find the minimum element as well. Right, this is how you can find the minimum element. Anyone is having any doubt up till here? I don't think. Right, so what I'll be doing is I have marked my flag as 0 as well in this part. So what I'll be doing is I'll be saying that for I starts from 0, I is lesser than n and I plus plus, and I will check that if a of I is not equal to b of I. Right, in that case what will I do? If it's not equal, then in that case I'll say that let's push all the elements which are let's or even I cannot do that. I don't need to take a vector in this case. You can do this in this way only. If it's not equal, then I will check that if my a of I is modulo minimum element, if it's equal 0, then I'll say if it's not equal to 0. Right, if it's not divisible by divisible by the minimum element, so in that case I'll mark my flag as 1, indicating that the array cannot be sorted further. Right, after once I'm done with this part, so what I will do is I will check if my flag is equal to 0. So that means that if the array can be sorted, that means that if the all the elements which are not at their particular position, if they are divisible by the minimum element, so in that case their GCD will be nothing but minimum, right, mi. So that is why they can be sorted. So in that case I'll print a yes. Right, I'll print a yes and I'll do an end. Right, else what I'll do, I'll print a no. Right, so this is what I'll do. And now let me copy this, as well as let me copy the test cases and see whether it works on the samples or not. Right, so is this much part clear? If it's clear, you can just consider giving a +1 in the chat. If AI is greater than, yeah, right, if AI is greater than, yeah, so I'm breaking if AI is greater than, yeah, I need to break in this condition. Right, okay, perfect. This is something that I missed. Now let me define ll hash right, so let me see whether this works or not. Okay, I needed to print a yes and I am doing that, but still okay. Right, perfect, missing this part. Now let's see whether it works or not for this case. It should get compiled at least. Yeah, it's giving a yes, yes, yes and no. Right, so let me copy the code and let's submit it and see whether it works or not. Right, okay, let's submit this problem and see what is the response that we get. You can see that this problem got accepted, right? Can you see that it got accepted? I think you can see that, right? It got accepted. So let me show you the code once again. Basically what I've done is I have taken the array as an input. I've made a copy of this array. I've sorted the copy, and also I've checked if the array is not sorted. If the array is not sorted, then I have marked my flag as 1. If my flag is still 0, so that means it is sorted, so that's why I'll print a yes. Otherwise I'll mark my flag as 0, indicating that maybe I can still sort it, right? I'll get the minimum element, and if the particular ith element is not at its position, so what I will do is, if the ith element is not at its position, so in that case I'll say that okay, let's see whether it is divisible by the minimum element or not. If it's divisible by the minimum element, then in that case the GCD of AI and the minimum will be nothing but the minimum element. So in that case I'll mark my flag as 1, and I'll simply say that okay, if it's not divisible, then in that case I'll say let's mark my flag as 1, and in that case I'll be printing a no. If my flag is 0, so I'll print a yes, right? So this was this problem that we have discussed, right? Now just quickly give me a +1 in the chat if everyone is clear with that problem, because I wanted to move to the next problem as well. Next problem is also pretty easy, and it won't take much time as well, right? Shall we move to the next problem? You can just let me know in the chat. So the next problem is named as RationalLee. So it says that you have been given an array a1 up till an, and you have k friends, right? You have been given an array and you have k friends, and you have to distribute all the integers. You have to distribute all the array elements. You have to distribute all the array elements, right? You have to distribute all the array elements among all these friends, right? Such that the ith friend will get exactly wi amount of integers, right? The ith element will get wi amount of integers, right? The ith element is gonna get wi amount of integers, right? This is what it is going to get. Okay, is this much part clear to everyone? You can just let me know in the chat if it's clear. Okay, right? So what it says is, you have been given an array, right? You have been given an array. Let's take this. Okay, so this problem is very easy according to me. So this problem says that you have been given an array, and these array elements are having some value, that is ai value for the ith element, right? And you have k friends, right? You have k friends, and let's say for a friend, for a friend wj, let's say for a friend jth friend, he wants, let's say for wj, for him is 3. So in that case he will want 3 elements. So he will want 3 elements, so that means this element, this element, this element, any 3 elements you will give him, right, from the array. So it says that whatever total summation of wj, such that j starts from 0 and j is equal to k, right? J is equal to k for all the k friends. What will happen is that the sum will be equal to the n, right? So this means that there is a particular friend, jth friend, and he is demanding some amount of elements from the array, right? So in this way, what you want actually is, your task is to allocate the number of elements in the array, that is wj, for a particular friend that he wants. And after that, what you will be doing is, let's suppose that some friends get something, right? Let's take one example. Let's say if you had n is equal to 10, right? If you had n is equal to 10, and one friend wanted 2, one friend wanted 3, and another friend wanted, let's say, 1, 2, and 4 and 5, right? So if you had 10 elements, so you will give 2 elements to this friend, right? Since wj for him was 2, right? If the wj for this friend is 3, so you will give 3 elements, right? 3 elements. And for this friend you will give 5 elements. So in this way you can see that all the total 10 elements will get distributed, right? So now you will also be getting the minimum element from here, right? The minimum element that you have given this friend, among these two elements you will also be having one minimum element and one will be the maximum element, right? In this array also, one element will be minimum and one element will be maximum, right? in this array also one element will be minimum and another element will be maximum, right? So you need to find the sum of all these elements, that is mi for this array, mx for this array, mi for this particular friend, and mx for this particular friend, mi for this particular friend, and mx for this particular friend, and you want to maximize this sum, right? Is this much part clear to everyone? Please quickly let me know in the chat. Is this much part clear to everyone? Please quickly give me a +1 in the chat if this much part is clear to everyone, right? Is this much question clear to everyone? You can just let me know in the chat. Is this much question clear to everyone? Only then I'll be able to proceed further. Is this much part clear to everyone? What about you, Ria, Chirag, and other guys, other people? What about you all? Aniket Yadav is giving a +1. What about others? You need to let's say this friend wants 2, this friend wants 3 elements of this array, this friend wants some of the elements, right? So all these elements are having ai value, aj value, right? Some values, right? So let's say this friend gets 2 elements. So for this there will be one minimum element, one maximum element, right? So in this way you'll want to sum all the minimum maximum element for all the friends, and you need to make this sum maximum possible, right? If it will be more clear through the test cases, okay, no problem, right? It will be more clear through the test cases, right? Okay, so let me see the test cases as well for this problem. Let's have a look at these test cases. Let's take this first test case. If I am having number of elements is 4 and my k value is having 2, that means I have 2 friends, right? I have 2 friends among whom I have to distribute. One friend is wanting 1 element and another friend is wanting 3 elements, right? So in this case what will happen? I have the array 1, 13, 7 and 17, right? Can I say that if I allocate this friend 1 and if I allocate this friend 13, 7 and 17, so for this the minimum element is 1, the maximum element is 1. For this the minimum element is 7 and the maximum element is 17. I add all these up, so this is 2, this is 9, this becomes 9, and then 9 and 17 becomes 26, right? Now there can be a lot of combinations like these possible, but what happens is, let's say I redistribute these elements in this manner. Let me tell you how. I redistribute it. If I will distribute it like this, if I give this element as 17, if I give 17 to this and I give 1, 13 and 7, so in this case this becomes, the minimum is 17, the maximum is also 17, and in this case the minimum is 1 and the maximum is 7. So this is nothing but 34 plus 8 gives me 42, right? Let's check the answer. Yeah, for the 40 we are getting a little different answer, right? Why are we getting a different answer in this? Maybe we might have made some mistake. So they are saying that you can take 17, 17 and 13 and 1, 14. Yeah, 13 and 1. Yeah, the maximum element is here is 13, not 7, right? Since the maximum value is 13, so that is why the overall value will be 34 plus 14, so that will give us 48, right? So this will be the maximum sum for this. Is this test case clear to everyone? No, Divyansh, we are not doing sorting problems only. We have done problems on game theory as well. We have also done sessions on greedy algorithms as well. Apart from this, we have done several editorials for CodeForces around. So we are not only focusing on sorting. We have discussed about a lot of other topics as well. So you can check out the playlist on the channel, and in that you will get aware like what topics we have discussed, right? Is this clear? If this much is clear, please quickly give me a +1. Quickly give me a +1 in the chat if this much part is clear, right? If this much part is clear, you can just consider giving me a +1 in the chat. Okay, Ria is giving a +1. What about others? You can also just give me a +1 so that we'll be able to move ahead with this, right? Now, perfect. Okay, clear, right? It's clear to most of the people, correct? Perfect, right? So in this way, can I say that there can be several friends like this, right? There can be several friends, right? There can be several friends. Let's say this is a friend. So you saw that if I put 17 here, then I will get 17 plus 17, right? So if I have just, can I say that if I just have to for a particular friend, if the if for a particular friend wj for that particular friend is nothing but 1, so in that case can I say that if the wj for that particular friend is 1, so in that case I'll be giving it the maximum element possible, right? If that element is having only 1, so in that case can I say that I'll be giving it the maximum element that is possible that I can give it, right? Because it will be adding 2 times, because 17 will be the maximum element as well as the minimum element, so it will be counted twice. So that is why I'll like be increasing my answer, right? Is this much part clear to everyone? Like, there are two cases. One case is when a friend is wj for a friend is 1, and another case is when the wj for a friend is greater than 1, right? These are the two cases that you need to notice in this problem. Is this much part clear to everyone? I hope that it is. If it's clear, then please write clear in the chat, because I want this part to be clear from all of you. Only then I'll be able to proceed further. Is it clear? Is this much part clear to everyone? Yeah. Well, what about you, Ria? You can just let me know in the chat. Right. Let's say if I have these elements, let's say I'm having two friends in such a way that to each of the friend I have to distribute three elements, right? I have to distribute three elements to each of the friends, and I'm having 10 and 11, right? I'm having 4 tens, right? In this, what will I do? In this case? What will I do? First of all, since I want the maximum element to be present in both, right? If I put 11 and 11 in these case, 11 and 11, right? Let me just change the color of the pen, right? If I put 11 and 11 in this both, then I also need one element, so that is I will need require 10. So that means that my here the sum will be 10 plus 11, right? But in that case what will happen? All the rest of the tens will have to come here, right? So that is not good. That's not good, because 10 plus 10 plus 10, that is 30, and overall answer will be, the maximum answer here will be 41, right? But can I do something more better than this? Let's try and see whether I can do something better than this or not, right? So let me just erase this much part, right? So let's say that if I have the three elements, and if I have the three elements here, right? So if let's say I give 11 to this element and 11 to this as well, so can I say the maximum here is 11 and the maximum here is also 11, and I distribute this 10 here, this 10 here, right? So that means 10 and 10, and the rest two of the tens here and here. So that means this is plus 10 and this is plus 10, the minimum element is 10. So that means 21 plus 20 gives me a, not 21, 22 plus 20, right? 22 plus 20. So 22 plus 20 gives me what? 22 plus 20 gives me nothing but 42, right? So this is the maximum possible, right? Is this much part clear to everyone? Because only then I'll be able to proceed further. Is this much part clear to everyone? I want to take another example, so I just wanted to know if this much part is clear to everyone or not. Only then I'll be able to proceed further. Shall I move ahead? Okay, perfect. Is this test case clear to everyone? Please quickly give me a +1 in the chat if this test case is clear to everyone, right? Now I want to take another test case. Shall I take it? Let's say there are some number of elements. Let's say I have a couple of 0, 1, then let's say I have also got a 1. I have also got, let's say I got some several 2's, right? If I have got some 2's, this is 2, this is 3, this is 4, this is 5, right? This is 6. So let's say in this case I am having 1, 2, 3, and then 3, and then 1. That means 3 and 1, right? Yeah. in this case, how will I write my answer? In this case, can you tell me the maximum sum? Can I say that whatever which is the maximum element? The maximum element is 6, so I'll allocate the maximum elements one by one. I'll be allocating the maximum elements to the single elements first, right? Single the people who are taking only one element, because this will be 6 plus 6, right? If even if I had some other, so I would have allocated 5 to it, right? In this way, right? First of all, my priority would be to allocate the maximum elements to the single ones, right? This is what I would have tried to do. Now next up you will say that, okay, let's allocate this 5 to this one, right? Let's allocate 5 to this, and let's allocate 4 to this, right? After that, you might have said that let's allocate this 0 to this element, and this 2, then this 2, and then this 3, right? So in this case, you might have allocated it like this. You must have said that let's allocate the in the same way, that is maximum element for each, and after that, first of all, this 0 to this 0 to this, right? So in this case, what would happen? This is nothing but 0 plus 4, and this is nothing but 2 plus 5, right? So that gives me 4 plus 7 plus 12, that is nothing but 16 plus 7, that is that gives me 23, right? Can I get better than this? Can I get better than this? Yes, I can get better than this. How? Notice one thing. The task here is not based on the maximum element only. I have to maximize my minimum element, right? I have to maximize my minimum element. That is the task, minimum element, when my wj, that is the number of elements that a particular friend wants, is greater than 1. How? Instead of doing this, what I could have done, let's see, this is 3, this is again 3, and this is 1, right? So instead of doing this, what I could have done is I could have marked this as 6. Let's say this is 6, so the sum is nothing but 6 plus 6. After that, what I could have done is, let's say if I say that up till here the minimum is 0, right? But can I increase the minimum for this? Can I increase, instead of having 2, can I have any other element as the minimum? Can I have any other element as the minimum? Yes, I can have it. If I allocate all these elements, like I have allocated, let's say, first of all 5. First of all, I allocate 5 and 4. After that, what do? I allocate 0 and 2 to this, and then 2 and 3 to this. So in this case, it is not possible, right? But let's say that if this element was let's say if I take 1 and I take 2, right? So if I'm taking 1 and 2, right? If I'm taking 1 and 2, let's consider this case. Let's say that if I increase the elements, right? If I increase the number of elements, what I'm saying basically is that let me draw it. Okay, yeah, what I'm saying basically is, let's say you have 4 here, you have some elements here also. Let's say you have a several ones, right? If the element is 5, let's say you have 1 1 and 2 and 2, right? So will you allocate this one and then this one and then this 2 and then this 2? If you do it like this, then the sum is 1 plus 4 plus 1 plus 5, that will give us 11, right? But let's say if you try to re-evaluate your situation, and you have given 4 to this, you have given 4 to this. After that, you give both of these ones to this, because the minimum element for this is gonna be 1. The minimum element is 1 and the maximum is 4. Why are you making the minimum element for this as 1? Why are you making the minimum element for this as 1? Instead of making the minimum element for this as 1, you should make the minimum element for this as 2. You should try to maximize the minimum element for the next array. So you put all the minimum elements for this. If it is sacrificing, if it is getting the minimum as 1, so put all the other elements, all the minimum elements next to it here as well. Put this 1 here as well, and put this 2 and 2 here. In this way, the minimum for this will be 2 and the maximum for this will be 4. The minimum for this will be 1, the maximum for this will be 4. That is 5 plus 6, that will give us, and not 5 plus 6, am I doing some mistake? I might have done a mistake here. 6 and this is 10, sorry. This is not 10. 1 plus 4, right? Okay, this is perfect, this is 11 only. Let me do this. Okay, right. So this is not this is what? This will be 1 plus 4 plus 4 plus 2, right? Not 4, man, this is 5. That is why I was getting an error, right? So this is 1 plus 4 plus 2 plus 5, so that gives me what? That gives me a 12. Can I say that in this way I can maximize it? If you have the minimum elements, just push that, right? Just push all those elements here only, because if it is, why will you make the minimum for this as 1? Try to put all the minimums one by one. Just push all the minimums here, just push all the minimums here only, right? In this way also, just push all the minimums here. If there are several threes and there are these elements, so why will you put a 3 here, 2 here, right? If you put 1 here, the minimum 1 is here, the minimum 1 is here, minimum 2 is here, so that doesn't make sense. That doesn't make sense. Try to make the minimum here 2, try to make the minimum here 3, right? How you can do that? You can allocate these first of all to here, and then 3 and 3 will be left, and let's say another element was 8. So in this case I can maximize, right? Is this much part clear to everyone? If this much part is clear, please quickly consider giving me a +1 in the chat, right? I hope that this much part is clear to everyone. Is it clear to everyone? I hope that it is clear, right? Is it clear? Is it clear? Is it clear? Is it? Please write a +1 in the chart if it is clear, right? Put the minimum elements into one array, right? This is what I'm trying to say. For Ria it is clear. What about you, Chirag? Right? It's clear, right? So that is what I'll be also trying to do for this problem, right? And I'll be using sorting for this. So can you suggest like how we should write the code for this particular problem? Anyone would like to suggest? Let me tell you how we'll write the code for this. First of all, I'll be having long n and I, then I take c in n, and I also have to take k, right? So I also take k, right? After that I also need a sum which will be initially marked as 0, right? So this is how I need it. Then I also need a long array of n, right? Also I need a long array of n and w of k, right? This is all I need. Then I'll be taking first of all the input for the array, that is I starts from 0, I is lesser than n, and I'll do an I plus plus. I'll take c in a of I, that is I take the array as an input. After that what do? I take the friends input, that is how many, for each friend how many does it want, right? So I'll do an I plus plus here as well, and I take c in w of I, right? I take w of I, right? Once this much part is done, so what do I need to do is I need to sort both A and B in sorted order, right? Because I want A to be in sorted order, that was clear, but I also want W to be in sorted order. Can you tell me the reason for that? The reason for that is very simple. The reason for that is because if it is only 1, so in that case I want to, if there are only in place of W, if there are only ones, so I want to allocate all of them first of all, right? I want to allocate it to all of them. So that is why I want them to be in sorted order, right? After this what I can do is I can start my I from 0, I will be lesser than k, and I plus plus, and what I'll be doing is I'll be checking. I'll be first of all, you know that the maximum element will be what? Can I say that the maximum element every time for every particular element? Can I say that the maximum element will be nothing but a of n minus 1 minus I, right? The maximum element will be this, that is the element from the back of the array. The element from the back of the array, that will be the maximum element, right? This will be the maximum element. And can I say that if my w of I for a particular element, if it's equal to 1, so in that case I need to add this maximum element 2 times, right? This will also be the minimum element for me, right? So can I say that for this element my sum plus is equal to what? Mx plus mx, right? Because the minimum element is also the maximum element here in this case, right? Else I need to find the minimum element as well. So can I say that the minimum element in this case will be what? Can I say what will be the minimum element in this case? Can anyone let me know in the chat? Anyone would let me know, right? Also notice that p will be there. Let's say a pointer ptr is there, which is marking n minus k, which is initially marked to n minus k. That means the elements in the sorted order, the index n minus k, right? You can try to do this with a dry run, it would help you, right? After that what do I need to do next? I need to check it, right? I need to check it that how many times I need wi, right? First of all I need to do a w of I minus minus, that is the current element is done, right? Then what I'll do is while w of I minus minus, I'm doing this while I'm decreasing its value, right? The current value, what I'll be doing is I'll be decreasing my pointer. I'll be decreasing my pointer, right? I'll be decreasing my pointer, and the minimum element, whichever will be the minimum element, I'll be allocating that, right? In this case, I'll be decreasing my pointer, and whatever is the minimum element that comes at the end, I'll be allocating that to myself, right? I'll be allocating that to myself. Is this much part clear to everyone, right? So for this, can I say that the minimum element here will be nothing but a of ptr? You can try it out, right? If let's say, if initially you are doing it, so whatever is the number of friends, you start from n minus k, right? You will start from n minus k. How is it clear? Is it clear to everyone? You can just let me know. Like why n minus 1, I can tell you. Let's say if I am having, let's say n is equal to 10, right? And I am having, let's say 1, then I am having 2, then I am having 3. So 1, 2, 3, 3, 3, 6, and then I am having 4, right? So what do I mean by that? Let's say I am having the elements from 1 to 10. Okay, so let's say the elements are from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? These are the elements that I want to allocate, right? What is the value of k here? The k is nothing but 4. What is the value of n minus k? The value of n minus k is nothing but 10 minus 4, so that gives me 6, right? So from this element I'll start allocating, right? Why? Because all these elements are reserved. All these elements, I'll put this 10 here, I'll put this 10 here, I'll put this 9 here, I'll put this 9 here, I'll put this 8 here, I'll put this 7 here, and after that I will allocate from here, right? I'll allocate the elements from this part, right? I will allocate the elements from here, right? I'll allocate the elements from here, right? Is it clear? That is why I'm doing an n minus k. I'm initializing my pointer to this position, right? Right. So what will happen in this case? In this case, can I say that the minimum element will be what? The minimum element will be nothing but this element only, right? The minimum element will be 6, and in this way I can allocate. You can try to do it, right? So that is how I am doing it. You can just try to dry run this code, right? This was a little bit trick, like how you can do it. Even you can do it in a much simpler manner. If you have any simpler manners, you can let me know in the comments as well, right? I'll add the minimum and the maximum element, right? And once I'm done with that, so I'll simply, in the end, I'll see out my sum, right? So this is what I'll do, and let me copy the test cases in this problem. Let's see what happens. Hopefully it should work. Yeah, 42, 48, and 8000, whatever, 8 into 10 to the power something, right? So I can let you know with a dry run as well, don't worry. Please let me know if this much part is clear to all of you, or if you are stuck somewhere, then where you are stuck. Like, I hope that n minus k approach is clear to all of you, right? So let me just do this. Okay, right. So basically what I'm saying is, now I am left to allocate from, it got accepted, right? You can see that it got accepted. Basically what I'm saying is, you for the first k elements, the largest k largest elements of this array, you'll be allocating them one by one, so that they are maximum possible, right? This will be 10, this is 9 here, right? In this way it is there. But now you need to allocate the minimum elements. And how will you do that? What will be your maximum element each time? That is also one of the situations that you need to notice, right? So one thing is for sure, that this 6 will be, I'll be putting this 6 here, right? I'll be putting this 6 here. That's perfect. But now I have what? I have let me just do this. Okay, I have now 1, 2, 3, 4, and 5. Now my pointer is here. I need to skip 2 elements, so that is why this element is skipped, and then this element, right? So that is why my pointer will point to this 4, and this 4 and 5. So this is the minimum element for this will be 4, this will be 8, this is 6 plus 9, and this is 10, right? And now similarly I do it for this. So these are the 3 elements that are left. So that is 1, 2, and 3. So can I say that whenever my pointer is here at the last, whatever elements I have done, so that is why a of pointer, that is the minimum element will be a of pointer, whichever element my pointer is pointing after my while j of minus minus has get exhausted, right? Because I don't want to fill these elements, so that is why I'm not considering them. So this is how I'll be doing it, and this is nothing but 1 plus 7. So in this way I'll get the maximum answer possible, right? So I hope that this much part is clear. If this much part is clear, please quickly give me a +1 in the chat. You can just consider giving me a +1 in the chat if it is clear. If it is, even if it's not clear, don't worry, I'll provide you with the code in the description. So thanks a lot everyone for watching this video, and if you have any doubts, so feel free to mention that in the comments. And you can, if you're watching the recording, you can like, you can share this video with your friends with whom you are doing pair coding or something like that, and you can also subscribe to this channel if you haven't done that. Also, I'll be bringing later in the evening, I'll be bringing the lead code daily challenge as well with the recording, right? So that's it from my side for today, and I wish you all the best and keep coding. And soon, I'll maybe from tomorrow I'll start a new series. I'll let you know, you'll get updated. Just check out on the channel, keep checking out on the channel, right? Also, you can just DM me on LinkedIn if you want to know, right? So that's